about asteroids. So, my friends, first of all, I would like to share with you the console of the telescope. Let me see if I can do this right away, because the weather tonight looks very good, and honestly I'm very happy for this, because you never know with the weather what will happen. So, I don't know if some of you are already familiar with our technologies. This is the console of our main robotic unit available in Manciano, Tuscany, in the beautiful landscape of Maremma. Basically what you are seeing here is the night sky above our observatory. And from time to time you will see some red or yellow circles somewhere in the star map, and they have a precise meaning. The yellow circle map, and they have a precise meaning. The yellow circle is the actual pointing position of the telescope. In other words, the telescope is looking where you see the yellow circle. The red circle is actually the location of the object we would like to see. That is the object, the target object we will ask the system to point. At this very moment the telescope is just pointing a random position, but in order to bring to you the best possible experience, let me see if I can add this site. Just wait for a minute, my friends. Just trying to share with you also the image of the telescope, which is something I don't know very often, but as I say, this is a very special night. So let me see if I'm able to share with you this site. Where it is? Here it is. I should have done. Here it is. So the silhouette you see here is the actual telescope I'm going to control with you tonight. And let me see if I can reduce the image a bit, so that we can work on both the windows, that is both the telescope and also the star map. Let me see if this is the best position. What I want to do now is just to ask the telescope to slew and point the first object of tonight. I will start with an asteroid which is not far from the actual pointing position. Here it is. And this asteroid, 2003, hey, okay, just checking, no, I had an alert. Okay, this asteroid 793349 is actually a near-Earth asteroid, and I will tell you a bit more in a few minutes. Anyway, let's go and start slewing the telescope to this real asteroid, and you will see the telescope moving also in the window I shared with you. This is why I wanted to share that side with you, because right now the telescope is moving in real time thanks to our technology. I am about 150 kilometers away from the observing site, and no matter this, we are enjoying such a unique opportunity. The Virtual Telescope project has been supporting Asteroid Days since the very first edition. Now we are sitting on the right spot of the sky, and in fact you see that the yellow circle and the red ones are just on the very same position. Oh, I did perhaps a mistake, sorry, but no matter this, you are enjoying a gem of the night sky. The object we are seeing right now is a globular cluster, and which is a completely different story, which is about 30,000 light years from us. For sure, this is not a near-Earth object. Anyway, let's ask the system, which is very close, as you see, in the same spot of the sky. I want to enlarge the star map. At the scale I was using earlier, it was not easy to recognize, to separate the globular cluster where the telescope is looking out to the real asteroid. Now we are able to do that and ask for this change. The telescope yellow circle is now sitting on the destination, the red circle, where the near-Earth asteroid 733349 is. And now I bet you if you can recognize where the asteroid is. Absolutely no. But now we will start taking an image. I ask my system to track the asteroid at the same rate, just to use every minute. Now that I start taking the exposure, I will tell you what is going to happen. First of all, happy Asteroid Day again. We are celebrating this year the 10th anniversary of this amazing initiative. Asteroid Day started, as I say, 10 years ago, and it was founded by Brian May, the legendary guitarist and also astrophysicist, a planetary science scientist, the legendary guitarist of the Queen rock band, Greg Richter's, Rusty Schweiker, the Apollo 9 astronaut, and Dani Karemi, very good friends of mine. And since then, Asteroid Day has tried to increase awareness about asteroids, and this is why we are happy to celebrate this event. Since 2016, the United Nations recognized Asteroid Day as an international day to be celebrated every year on the 30th of June, because the 30th of June 1808 we had the Tunguska event, the most important asteroidal event happened in recent history. Luckily for us at that time, the event happened in Tunguska, a very, very remote place with no consequences, no fatalities, but that event just reminded us about the hazard posed to the Earth by asteroids. This is why Asteroid Day is celebrated every year on the 30th of June. And Asteroid Day is here not only to remind us that asteroids can be a problem for us, so we need to learn as much as possible about them, discovering them, just evaluating their orbits, calculating, estimating the probability of an impact. But the novelty is that now we can also face the impact risk, and hopefully we can actually manage it. We can mitigate it. So we are just taking images of the asteroid. I will tell you which is the asteroid. Let's see if you can recognize now the asteroid. I want to enlarge the image a bit. And it is nice to see a real asteroid while we were remembering about the origin of Asteroid Day, to make the world aware about the risk coming from potentially hazardous asteroids, near-Earth objects, but also about our capability to mitigate such a potential risk. But also we know that asteroids can be precious resources, and some important materials are out there on asteroids, and in the perhaps near future we will be able to mine asteroids with plenty of benefits for our technology and our space missions in the future. But now back to the real asteroid. Perhaps you can understand now who is the asteroid here, because I asked the telescope to track the motion of the asteroids while it is moving against the starry background. And of course, if that is true, the sharp dot of light here is the asteroid 793349, and the telescope tracking it made possible for us to see the asteroid like a sharp dot of light. So all the stars on the background are leaving short trails. This object is very nice, very bright, as you can see. Let me see also if I can tell you the distance of this object at this very moment. If you don't mind, I want to check this on the previous database maintained at the Jet Propulsion Laboratory in California. And this is an interesting target, by the way. This asteroid is not only a near-Earth asteroid, but it is also a potentially hazardous asteroid. I used this definition several times now, near-Earth asteroid, potentially hazardous asteroid, but what do they mean? Let me try to show this essential graphic, if you don't mind. Here it is. You know, we discovered the first asteroid on the 1st of January 1801. The discoverer Giuseppe Piazzi actually located it from Italy, so I'm proud of that. He was observing from Palermo Observatory at that time. Since then, over more than 2 centuries, we actually discovered almost 1 million asteroids. But luckily enough, most of them are between the orbits of Mars and Jupiter, in a very remote place, I would say a safe place. So they are really no reason of concern for us. Every normal, I would say ordinary asteroid living between Mars and Jupiter, a region that we call for obvious reasons the asteroid belt, is really no reason of concern for us. The problem comes from those objects able to reach the inner solar system, that is where our planet is, and this graphic is making the idea, I think, quite clear. You have the Sun, the yellow dot, the orbit of the Earth, and also the orbit of 4 different types of near-Earth asteroids. First of all, a near-Earth asteroid, for obvious reasons, and the name is clear, is an object able to come in the proximity of the Earth. Near Earth, it just means it can be close, pretty close, very close, extremely close, it depends. You have several classes of these objects. You can see there are asteroids approaching the Earth of the orbit, but never crossing it, like the Amor ones. Then you have the Apollos that can, on the contrary, cross the Earth orbit. Then you have also the Aten asteroids. They still cross the Earth orbit and spend most of their time inside the Earth of the orbit. And then you also have this intriguing category of inner Earth objects, also called Atiras, and they have orbits entirely inside the orbit of the Earth, so they can approach our planet from the inner of its orbit. These 4 classes basically summarize the near-Earth asteroid population. They are different ways to approach our planet: the Apollos, Athens, Amors, and Eos, and they are very interesting, as I said, because coming possibly very close to us, they can collide, they can hit our planet. But you can be a near-Earth asteroid, and you can have also another tag on you. Not only you are a near-Earth asteroid, but you can even be a potentially hazardous object. In order to be a potentially hazardous asteroid, you must satisfy 2 different conditions. You have to be larger than more or less 140 meters, and you have to come at least as close as 7.5 millions of kilometers from the orbit of the Earth. In other words, every object larger than a given size, 140 meters, and able to come closer than 7.5 millions of kilometers, not only is a near-Earth asteroid, but it is also a potentially hazardous asteroid. Please, this is a definition, just using 3 words: potentially, hazardous, asteroid. And to me, the most important word here is potentially. Being a potentially hazardous asteroid, it does not mean at all that it is going to hit us tomorrow. It just means that you are large enough and you are able to come close enough to me, I mean planet Earth, that it is much better that I keep an eye on you. Among, as I said, about 1 million asteroids known to date, there are about 30,000 near-Earth asteroids. Just to give you an idea, they are relatively rare, I mean the near-Earth asteroids considering the whole population, but still, as I said, they are enough to suggest to keep an eye. We are approaching actually 40,000 near-Earth asteroids, that is the objects coming relatively close to us and satisfying one of the 4 conditions we are seeing here: Apollo, Athens, Amor, Eos. And among them we have about, I want just to read the latest statistics, we know about 2,500 potentially hazardous asteroids. So, to summarize, 1 million asteroids in total known to date, more or less. Most of them are between Mars and Jupiter, very far away to be reason of concern. But in the stake I mentioned, you have about 40,000 asteroids able to reach the inner solar system, where the planet Earth is. And they are the near-Earth asteroids. Among them, we consider a smaller population, about 2,500 objects, named potentially hazardous asteroids, because first of all they are near-Earth asteroids, but they are also large enough, larger than 140 meters, and able to approach us within 7.5 million kilometers. I hope that this made the things clear, and I also want to show you this intriguing graphic made by a colleague several years ago, when you can see at a given typical, I mean, no matter the date, you can plot the entire asteroid population in this map between Mars and Jupiter. You know where every asteroid, knowing the orbit, where the asteroid is, and you can plot where at a given moment all the asteroids are, and you can see, as I said, that many of them are between Mars and Jupiter, the asteroid belt, and you can see that some of them are also in the inner solar system, the near-Earth asteroids. I love how everything is clear at this point. And then you also have other kind of objects. But let's go back to celebrate these objects. I want to go back now to our console. This is the potentially hazardous asteroids 793349. Now I stop taking images of it, okay, because I would like to salute the telescope and observe something different, which is here in a very different position of the sky. While I will ask the telescope to observe this other object, I will be happy, if you don't mind, to show the telescope pointing. So let's ask the telescope to go there. Okay. And now perhaps you can even hear some noise made by the telescope moving. I love how all these toys work. I'm amazed. I want to underline this. The telescopes are alone no humans are there. I am, as I said, 150 kilometers south from them. You are where you are, somewhere on this beautiful planet, and it is amazing how we can really have this opportunity to explore the night sky, joining this live feed from the comfort of our homes, with me having the pleasure to host you. I also want to remind and thank the technological partners of the Virtual Telescope project, Software Bisque, C-Web and Telescope Live. Now I think the telescope arrived. Let's check on the, yes, on the star map. It is already taking an image to refine the pointing. I really love how this system works. Okay, and now I want to take another image. So Asteroid Day, my friends, is around to remind us about the importance of asteroids. And what is, by the way, the origin of asteroids? Because we actually mentioned where they are, that we mentioned that they can be a reason of concern, but also we mentioned that they can be resources because they offer us, elements, material that it is not easy or absent on our planet. We are also now able to face the impact issue. In 2022, the NASA DART mission actually demonstrated we are able to change the trajectory of an asteroid, just organizing a collision between the asteroid and an object launched against it. And the DART mission actually succeeded, as I said, changing the trajectory on an asteroid, and the results were much better than hoped. So we are better than hoped doing that, just in case. So we are just training ourselves in order not only to find a potentially dangerous object, and in case also a certain impact. We are also working to mitigate the impact in case it is going to happen. But as I said, the Asteroid Day is now also reminding us about the importance for a young generation to consider careers in this field, the STEAM field, considering how exciting these days are. And I can tell as an astrophysicist that if I could have that power, I would like to to go into hibernation for perhaps 50 years, waking up and see what happened in half a century. Would be something that today is just a science fiction, because incredible things happened honestly during the last decades. And here it is, the asteroid we are observing now, 798412, also known as 2011 HEM-HEL6. Once again, the telescope is beautifully tracking the object as it moves across the stars. This is happening, of course, because the asteroid is moving on an orbit around the Earth, and as seen from the Earth, we see the asteroid in motion against the stars. So, in other words, the telescope just setting the tracking rates of the asteroid is making possible for us to keep in the very center of the crosshair. By the way, here we have also our crosshair, as I said. Let me say something about this object, by the way. Let me find the latest data, again thanks to the Minor Planet Center and the Center for Near Earth Object Studies at Jet Propulsion Laboratory. We also have an important office here in Rome at the Esrin facility of ESA, the Near Earth Object Coordination Center. These offices are doing an incredible job constantly estimating impact probabilities, even on just discovered objects. Okay, friends, let me find a few things about the object we are observing now, just making sure that I give you the latest data. Okay. Okay. I'm just finding the data, surfing a few things. So let me start from the object we observed earlier, which was the potentially hazardous asteroid 793349. That object is quite large. It's a diameter of about 500 meters. 500 meters. I really don't want an object of that size hitting our planet, in case it would have really tremendous consequences, almost at global scale. While the object we are tracking now, let me find where it is. Okay. It's looking among many objects while the system is capturing images back to back, as you can see. Okay, I have it right now. This object is a bit smaller, about 400 meters. So again, this is a huge object. And while we are imaging it, let me find the right datum. At this very moment, the distance of this object from our planet, okay, just doing this calculation right away. Okay, this object is a bit less than 15 million kilometers from our planet. Consider that our moon is 0.4 million kilometers, just to give you a scale to better understand the real situation, what we are seeing now. I'm just waiting to see if I was wondering, this is too low unfortunately, but I want to conclude with a very important asteroid, which is in the same spot of the sky as this one, the asteroid Vesta. You see, asteroids are reported as a number and a name, even if sometimes you have just a strange designation, a year and a string just telling the year of discovery and when during that year the asteroid was discovered. But when an asteroid is known pretty well, it deserves a number, final number, as in the case of Vesta. Vesta has been one of the very first asteroids to be discovered, so almost 2 centuries ago, and let's go while the system is not only showing us the asteroid, where you see here the dot of light, but also you see a clear trail from a satellite, an artificial satellite. But let's stop this and let's point Vesta. You have seen how faint, after all, those asteroids were. Well, Vesta has the potential to be visible to naked eye. So, asteroid Vesta is the brightest ordinary asteroid. It can be seen when it is at its best observing condition by naked eye, provided you have a very dark sky. And the asteroid Vesta is this very bright dot of light. It's incredible, as I said, to see now such a very bright object after we saw those much fainter targets we actually captured minutes ago. So Asteroid Day celebrates this year the 10th anniversary. I am proud to serve Asteroid Day as a national coordinator here in Italy. I've been in Luxembourg last week. Every year now, since 2017, in Luxembourg there are some incredible events organized by my friends at the Asteroid Foundation there. The Asteroid Foundation is taking care to organize every year the Asteroid Day, by the way. And I had the pleasure to meet many colleagues, astronauts, curious people, young people considering to have their future in space. And there are many careers. You can be an astronaut, you can be a scientist, you can be an engineer, you can be a lawyer studying from that point of view space, you can be an artist, and still very precious in such an effort to reach space, and perhaps sometime in the future even the other planets. So my friends, with this bright object, Asteroid Vesta, we are going to close this Asteroid Day celebration, Asteroid Day 2025 10th anniversary. I invite you to support the Asteroid Day mission. Visit asteroidday.org. My very good friends there are telling you many things about this event, which was actually founded, Asteroid Day, as I said, by the legendary Queen guitarist and planetary scientist Brian May, the movie director Grigory Richters, and the astronaut Rusty Schweickart, Apollo 9 astronaut, and Danny Karemi, president of the B612 Foundation, also doing a lot of work to help science of asteroids. That said, my friends, it has been a privilege to host this live feed, and I really hope you enjoyed it. At least I hope that you have found the experience worth of your time, and I still want to tell to all of you, happy Asteroid Day. Gianluca Masi, Virtual Telescope Project from Rome, sends you the best wishes and greetings, and I'm looking forward to see you joining our next amazing journey across space and time. Take care, my friends, and see you soon. Keep looking up, and happy Asteroid Day again.